Hey, Algebra students, welcome to our video on making and analyzing scatter plots. Now, fair warning, this is a complicated video. Now, first of all, making scatter plots, not hard. You can graph an XY coordinate pair, you can make a scatter plot. I'm not concerned about that part. The part that's going to be difficult is analyzing scatter plots because my guess is maybe you've talked about this stuff before, but when I talk about trend lines and correlation, it tends to be new terminology and it's not things you talk about every day. So make sure you're paying close attention during this lesson to terminology. And then the next video is probably the most important of the two videos where we're going to actually be making and analyzing. We're going to be getting hands-on with scatter plots. All right, let's get started with some definitions. First of all, what in the world am I talking about when I talk about a scatter plot? It's just a graph that relates two sets of data with ordered pairs. Okay. We've made lots of ordered pair graphs, and then you connect the ordered pairs with a line. The difference between what we've done before and a scatter plot is a scatter plot uses real world data, and real world data is messy. So, for example, something you're going to do in science class is measure if a car is moving at a constant speed, like a little toy car, it's moving at a constant speed. You need to measure its distance that it travels over a certain amount of time. Now, if it's traveling at a constant speed, it should have a very regular distance over time, which means that it's going to make a straight line, right? Well, yeah, more or less. You see, in the real world, when you measure things, there's always error in your measurements. Your measurements are going to be a little high or a little low, depending on how you read the scale or friction or air resistance or different things that can impact in the real world how things actually behave. So instead of being a straight line, wouldn't be uncommon if we're measuring how far a car goes over time for a graph to look like this. Notice that it's generally a straight line, it's almost a straight line, but the points don't really stick to an exactly straight line. And folks, that's the real world. Okay, that's real world data collection looks like this almost always because of error. There's error in measurements, okay? But essentially, we can see the straight line of the distance over the amount of time that this car is making. Now, what is a trend line? A trend line is a line on a scatter plot that shows the relationships between the two sets of data. What I'm going to do with this scatter plot, if I want to make an equation that represents how far this car moves over time, is I'm going to find a line that basically represents, okay, it's going to be somewhere in the middle between all these points. The one that I can figure out that maps these points the best I possibly can. If I were to find a mathematical way to find that line, not just a trend line, but I actually use a computer to calculate the best line, that's going to give me a line of best fit. A trend line that actually shows the most accurate linear relationship on a scatter plot would be a line of best fit. So a trend line you can make yourself. You can put a straight edge on this. The key to making a good trend line is to put like a straight edge on the graph and then find a place to put the straight edge where you have just as many points above your line as you have below your line. And that helps you make a pretty good trend line. Line of best fit, you need a calculator or a computer to find. And then our goal in all of this is to find something called a correlation. A correlation is just a measure of how strong the relationship between your variables, your data sets is. Not just how strong, but what is the direction of association. Okay? So you could have a positive correlation. You could have a negative correlation that looks like this, or you could have no correlation at all. Now, let's just clarify a few things here about these graphs. First of all, correlation is actually a number that has a minimum amount and a maximum amount. Correlation is always going to be between -1, which is the lowest correlation number you could ever get. But interestingly, the lowest correlation number, -1, is still a strong correlation. What a negative correlation means, like this one in the middle, as one number goes up, the other, look at the x-axis is going up and up and up. The x-axis is getting bigger. What happens on the y-axis? The number goes down. Okay. If there's a negative correlation, it's a graph with a negative slope. As x gets bigger, y gets smaller. Or as one of your variables increases, the other variable decreases. The highest number a correlation can take on is 1. So -1 is a perfect negative correlation. If it had a correlation of -1, all of these dots would be in a perfectly straight line. This would probably be a correlation of like negative zero point -0.9 here in the middle. It's close to -1, but it's not quite there yet. If one number gets bigger and the other number gets bigger at a regular rate, we say it's a strong positive correlation. This first graph is a strong positive correlation because as x gets bigger, y gets bigger too, and it makes a pretty good, obvious trend line. So again, if it was a perfect 1, that means that they would be all in a perfectly straight line. This again would be a positive zero point -0.9, just like this one's a negative zero point -0.9. That's probably about what the correlation would be. And then no correlation or zero correlation means that there is no relationship between the two variables. One doesn't predict whether the other one increases or decreases. And that looks like an impossible to identify. There's no line here. I couldn't say whether this is an increasing or decreasing line because these scattered points are just scattered all over the place. No correlation is actually useful information. It tells you there is no relationship between the things that you're looking at. All right, and there's to repeat, a positive correlation means that one data set increases as the other increases. Strong positive correlation means it's obviously an increasing line. The graph looks like it's obviously an increasing line. It's not super spread out, okay? Negative correlation means as one set of data decreases, the other increases, or the opposite way. One increases, the other decreases. And again, a strong negative correlation means it's an obvious line with a negative slope. This would be a strong negative correlation. No correlation, the variables are not related to each other. And that brings us to video 2, where we're ready to work some practice problems related to scatter plots, trend lines, and correlations. Let's get going on that one.